Today we are starting our unit on factoring. Today we're going to cover two types of factoring, GCF and difference of squares. So what does GCF stand for? It stands for the greatest common factor. So greatest means biggest, common means they have it in common, and factor just means it divides into the number. So if I'm looking at the greatest common factor of 16 and 24, this is what you should be thinking. Not necessarily writing it out, but this is what you should be thinking. Those are all the factors of 16. And those are all the factors of 24. Well, I want the biggest number that goes into both. So the answer is going to be 8. Now, 2 goes into both, 4 goes into both, but I want the biggest number. So the GCF of 16 and 24 is 8. The GCF of 12 and 18, 2 goes, but that's not the biggest. 6 goes, and that's the biggest. The GCF of x squared and x to the fourth is going to be x squared. But let's clarify some things. If I wanted the GCF of x to the third and x to the fifth, it would be x to the third. I can write x to the fifth as x to the third times x squared. So x to the third is a factor. If I have x to the seventh and x to the 12th, the GCF is x to the seventh, because I can write him as x to the 7th times x to the 5th. Because when you multiply, you just add your powers. So the kicker is when you have variables, you just always, the GCF is always your smallest power. So between these two, 7 smaller, so that's my GCF. If I gave you x to the 22nd and x to the 13th, the GCF would be x to the 13th. It's just always the smallest power. So what's the GCF of 169 x squared y to the fourth and 65 x to the third y squared? Well, 69, the only factors of 69 are 1 and 169 and 13 times 13. Now 65 may have a bunch of factors, but if it's going to have a common factor with this guy, I know it's not 169, so then I take my calculator and I do 65 divided by 13, and it goes. It's 13 times 5. So 13 is their greatest common factor. Now look at your x's. If I have an x squared and x to the third, remember you always take the smallest number out. And then y to the fourth and y squared, so I'm going to take the smallest y out. So that's my GCF. What's the GCF of a 25 and a 5? It'd be a 5. 5 goes into both of them. And again, take the smallest power. I have an x to the fifth and an x squared, so I'm going to take an x squared out, and then I have a y to the third and a y, so I'm going to take a y out. Okay, so now we're going to take it a step farther. Not only do I want to know what you're going to GCF, what you're going to take out, but I want to know what you're going to have left over. Now, number 3 has 3 terms, so I need to find a GCF for all 3 terms. So I have a 21, a 7, and a 14. So I know that 7 goes into all 3 of those numbers. Now, when you look at your x's, find the smallest power. So he has 5, he has 3, and he has 1, so I'm going to take 1. So now I'm going to write what I have left over. Well, think about this. GCFing is like dividing. So if I divide each of these terms by 7x, first term would leave me with a 3, x to the fourth, because when I divide, I subtract my exponents, plus 1 x squared minus 2, x's cancel, so I don't have any left over. Now, on the last lesson, we were working on distributing. So if on the last lesson I had given you this, then you would have said distribute, and that would have given you 21x to the fifth plus 7x to the third minus 14x, which is our original problem. Factoring is undoing distribution. So instead of distributing the 7x, I'm giving you this and asking you to factor out and write what you have left over. So number 4, I've got a 40 and a 36, and again, 2 goes, but I want the biggest number. 4 goes into both of those. So let's take a 4 out. And then y's, I've got a y to the fifth and a y to the third. So I'm going to take the y to the third out. and then I divide by what I'm taking out. So first term is going to give me a 10y squared, and that's going to give me a 9. The y is going to cancel. So that's GCFing and then writing what it has left over. 12 and 75. 75 is very limited. 75, if you think quarters, is like 25 times 3 and 75 times 1. The only numbers of those that go to 12 is going to give me a 3. X's, I have an x squared and an x to the 5th. So I'm going to take the smaller one out. Y to the 3rd and y to the 6th. So again, I'm going to take the smaller one out. So now I'm going to divide by this. So first term it's going to give me a 4. X's cancel and the y's cancel. And then that's going to give me 25 x to the 3rd, y to the 5th. And then number 6, 40 and 24. They're both even, so I know 2 goes. I know 4 goes, but I can go bigger. I think I can go 8. 8 goes into 40 and 8 goes into 24. So I think it's 8. And then he has an x to the 3rd and he has an x to the 1. So 1. Then this is interesting. He has y to the 5th, but he has no y. So since he has 0, I can't take any out. So then I divide by 8x. So that's going to give me 5x squared plus 3, x's cancel, y to the 5th. Okay, so now we're going to switch to the difference of squares. So your perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and 169. That gets me up to 13 squared. So to do squares, you have to have 2 terms. Absolutely have to have 2 terms. It has to be subtraction in between the 2 terms. All of your numbers must be squares. That means they all must come from this list, every one of them. And then your powers have to be even. X squared, x to the 4th, x to the 6th. They just have to be even. The difference of squares formula is really easy. Once you decide that all of this is true, whatever this is, you're going to pull it into its 2 separate squares, and whatever this is, you're going to pull it into its 2 separate squares, and then you're going to have 1 plus 1 minus. The reason you have 1 plus 1 minus, if I was going to FOIL this back out, a times a gives me a squared. A times negative b gives me a minus ab. That gives me a positive ab, and that gives me a minus b squared. I need, because my original problem only had 2 terms, I need my middle 2 terms to cancel. The only way to do that is if I have 1 plus and 1 minus. So in looking at these, so I'll look at number 7. I have 2 terms, yes. They have a minus sign in between them, yes. My numbers are squares, 9 and 4, yes, they're both on the list. And my power has to be even, yes. Once you get through all that, the factoring part is really easy. 9 is a square because it's 3 times 3. X to the 4th, just knock it in half, be x squared and x squared. And 4 is a square because it's 2 times 2. 1 plus, 1 minus. Number 8, 2 terms, yes. Minus sign, 36 is a square, and my power is even. 2 parentheses. Knock it in half. 36 is 6 times 6. 1 plus, 1 minus. Always, always 1 plus, 1 minus. Number 9, 2 terms, minus sign. 25 and 1 are both squares, and my power's even. First is going to be a 5 and an x, a 5 and an x, and 1's a square because it's 1 times 1. 1 plus, 1 minus. Number 10, these are 2 terms. They have a minus sign in between them. 16 is a square, and my power is even. 16 comes in the front, so when I go 4 and 4, that part goes in the front. X squared's in the back, cut it in half, that'd be x and x. 1 plus, 1 minus. Okay, this is what it looks like multiple choice. It says which expression is equivalent to 9p squared minus 100. These are squares. I have 2 terms. There's a minus sign in the middle. My 9 and my 100 are both squares. My power is even. So when I factor this, it's going to go 3p and 3p, 10 and 10, 1 plus, 1 minus. So I know it's not this one because they went 9 and 1. This one has 2 positives. This one has 2 negatives. There you go. Now when you get to something like number 12, especially if it's on non-calculator part, you look at a number like 484 and you think, good gracious, my brain doesn't go up that high. But it's multiple choice. Now I know 49 is going to be 7 times 7, so apparently 484 is 22 times 22. So if I think about this, that would go 7x and 7x, 22 and 22, 1 plus, 1 minus, which would be C. On your own, so this one, now we've got to determine if it's a squares or if it's a GCF. This one's a squares because I have 2 terms with my minus sign. So that would be P and P, 7 and 7, 1 plus 1 minus. And this is what is the GCF, so I'm looking for the biggest number I can. Most common mistake here is people take out a 5, but you can actually go bigger. You can go 15. X to the 5th and x to the 8th, I always take the smaller one out. Y to the 3rd and y, that's going to give me a y. So that is my GCF. Factoring is a super, super important cornerstone of the foundation of all the math that you will ever take. It is used over and over and over again. So it is definitely a skill that you need to make sure that you have very solid in your math repertoire. Tomorrow we're going to be working on trinomials. So really make sure that you're good with GCF and the difference of squares.